About the construct binary tree from preorder and inorder traversal. The question is give you two lists, preorder and inorder. Then you need to bank to do the traversal to construct the binary tree. So preorder and inorder should be the same size, and output will be different size. Since preorder have the same, it's the left child and the right child, then no, preorder should be root, then left, then right, and the inorder is left, root, right. Then you need to construct the new binary tree as 3, 9, 20, 0, 0, 15, 7. So how we do this, we need to figure out the rule to construct. So for example, in preorder list and inorder list, we create the index 0 to 4, and based on here we can find which is the root tree node. So in preorder list, the first one should always be the root number. So 3 in preorder should always be the first root number. Then based on the first root number in preorder, we can find the index, which is 1 in inorder list. Then in the inorder list, we can separate them as two subtree. Left subtree is 9, and the right subtree is 15, 20, and 7. Based on the inorder subtree left, we can find in preorder 9 is on the second one. Then we can find 15 as the third one. So how in the 9, we find 9 here. Here is 9, we find 9 here. Then in the left, we find a 3, and the 3 is the second one we find. No, then 9 is the first one we find. So 9 should be the root dot left. Then based on inorder, we find 15, 20, and 7 should be the right subtree. And based on here, we find in preorder 20 is the third node, and it is the root for the 3 dot right subtree's root. And based on the 20 is the root, we can find here the left and the right. So it's like a recursion to generate the whole reconstruct the binary tree. I hope I explained. Let me explain again in the code. So first we need to have a map, use a hash map to record one by one in the inorder list, since we need to generate the new binary tree from inorder list. So we make a hash map 9. You see here in order I we put. So in order 0 is 9, and it should be the index is I is 0. So 9, comma 0, 3, comma 1, 15, comma 2, 20, comma 3, 7, comma 4. Once we have this in order index, we can make a recursion. What should be included in the recursion is we have a helper function here, and the preorder. Preorder is this one, and the in order now is the in order index here. So preorder here, and we need to figure out the left and right. And in the in order index, we also have left and right. Then in the recursion helper function, in here, we pass all these values, and the base case is in left larger than in right. We return null. We can see this later. Let's see the recursion root first. So once in the root left and the root right, what should we do? So in root dot left, we need to figure out the preorder, and then preorder is the same as here function preorder. And this time in preorder, the pre-left plus 1 is the left function, is the left index. So you can see in here, 3 is the tree node, the tree root, and it should not include it. I mean, because the root dot left in the preorder, in the in order list, let me see if I get the wrong. In order is 3, 9, 20. In order is 3 here. I need to change here is in, and this is all pre. So okay, now it makes sense. So here in the preorder, the first one is 9, so 9 is our root. Then based on the 9, we can find the index is 1 in the in order list. So what's the preorder left? Should be 9, right? Because 3 is the root number. In the pre-left, root dot left equals helper preorder. Pre is 3, 9, 20. Oh, I make a wrong mistake. Pre and in. So pre is the, so 3 is the tree root number, and we can see in here pre-left plus 1. Yes, here. So 3 is the root number, because we can see from pre, we get 3 as the root number, and in the in order list 3 is here, and the 3 left sub tree shows 9 is the only number, and 1527 is the right subtree. So in the pre-order list, 9 is the second one, because 3 is already figured out as the pre-root number. So pre-left plus 1, pre-order list, pre-left is 0, and plus 1 is 1. So 9 is the left, root.left number we need to figure out. Then what's the right side? In the pre, it's the pre-left minus in-left plus in-order mid-index. So pre-left is 0. Then minus in-left is also 0. And plus in-order mid-index. What's in-order mid-index? In-order mid-index is the one we find the root value index in the in-order list. So here index is 1, which means 0 minus 0 plus 1 is 1. So the pre-order, in the pre-order list, pre-left plus 1 is 1 here. In the pre-right, so we are here now, pre-left and the pre-right. Pre-left is 1, pre-right is also 1. And it is true, so pre-left is 1, pre-right is also 1, so it's only 9. And in the in-order list, so in-order index is we have created in here. This is the hash map we created. Then we need to find out the left and the right bound. So in the in-order here, we can see, so 3 is the root. So it should be 0 and 0 for the left and the right bound, because it's only one number. And it is right because in the in-order index, in left is 0. In left is 0. That's correct. 9 is the index is 0. And then in-order mid-index minus 1, because 3 is the mid index, and minus 1, we need to find the right bound, so it's also 0. And the same as root.right, it's analyze. So in the root.right, in the helper function, we also do the pre-order, same here, in-order index, same here, and we need to find out in the pre-order left bound and the right bound. In the in-order list, we need to find the left bound and the right bound, yes. In the pre-order list, here is what we can see. Pre-order here, and the right side is pre-right. So pre-right is 4. 4 minus in-right is also 4. 4 minus 4 plus in-order mid-index is 1. 1 plus 1 is 2. So the left bound is from 2 to pre-right. So it's 2 to 4, which is correct, because 9 is the root, and the 3 is the left no, I'm sorry. 3 is the root, 9 is the left, and the 20, 15, 7 is the right subtree. See here, that's what we analyze here. And then in the in-order index, we know 3 is the root, 9 is the left. So the right root dot right should be only 15, 27 inside here. The right bound should be, the left bound should be mid index plus 1. Yeah, in order mid index plus 1. And the right bound is 7, which is index is 4, so in right. That's it. Okay, so we get the root dot left and root dot right. Let's see the base case, how this recursion works. So once it goes to 9, 9 here, the pre-left and the let me see, in left and in right here. Let's see here, in left and in right, and we can see here in left and in right, because in left is 0 and the in order mid index in this case is also 0. But then for next recursion, in left is still 0 and in order mid index minus 1 is 0. Then another time is 0 minus 1, so it will be minus 1. But it cannot be minus 1. So once in left is 0 larger than minus 1, which is not correct, we return null. So once return null, we can know the root number return in the recursion heap. What we return is the pre-order pre-left. So in the pre-order list, in the pre-left first time is 0. So 3 is the root we got. And in next recursion, we got 9. We got 9 here. Because in pre-left plus 1, pre-left minus in left, all these we find the left and the right bound in the root of left is 0, 0 is 9. So we return the pre-order pre-left is 9 here. You see this one. So pre-left, pre-order pre-left. What is pre-left? Pre-left is this one here, which is this one here, and which is this one here, and the index is 1. So pre-left is 9. We can find in the pre-order is here, and the tree node is 9. So root dot left is 9, and you can see here. And the same thing, root dot right. We find once the left is larger than right, we return null. And we can see the pre-order pre-left equals the root dot right in this case. So here what is pre-left? Pre-left is this one, and which is in here. Pre-left is this one. So it is 20 here. So why? Because pre-write is 4, and in-write is also 4. 4 minus 4 is 0. And the in-order mid-index is 1. So 0 minus 0 plus 1 plus 1 is 2. In the pre-order list, 2 index 2 is 20. And the pre-write is 7 in index 4. So 20 root dot write should be 20 here. Because this only pre-left, pre-order, in the pre-order is 20. That's how we get this one by one by one. And the end is also return null if it's in left larger than in right. And the complexity should be O n